let's explore the factorizations of polynomials that have special shapes. First, what do we mean by factoring? We can think of factoring as the opposite operation to multiplying. We could call it unmultiplying. That's what factoring here means. Let's start with factoring a positive integer 60. You see factor. We mean factor completely. We want the complete prime factorization of 60. Let's come up with one way to write 60 as a product of two integers. Lots of ways to do this. One is 2 times 30. And we ask ourselves, can 2 be broken down anymore? It can't. 2 is prime. 30, however, is not prime. It factors as, well, one way to factor it. There's more than one, but one way is 6 times 5. 5 is prime. 6 is not prime. We can factor 6 as 2 times 3. Now, at this step, every factor, each of these 4 factors, is prime. So we've now factored 60 completely. We will write it in this compact notation as a product of powers of primes. 2 squared times 3 times 5. Now let's factor a polynomial. Factoring polynomials is very similar to factoring integers. Let's see what we have. X squared minus 4. This factors as, this is actually a special shape. This is an example of a difference of squares. X squared minus 4, or x squared minus 2 squared. X squared minus 2 squared. This factors as x plus 2 times x minus 2. How about this one? How do we factor this trinomial? So the shape here is, this is in the shape x squared plus bx plus c. Should have written that in green. Let me circle it in green. And we want to come up with, you have x squared plus bx plus c. What you want to find are two numbers. Let me not use, certainly not use b or c again. Let me actually use the letters alpha and beta. We're going to find two numbers whose product, alpha times beta, is the constant term c. And we need them to add up to the middle term, b. So here, in this problem, we see that the pair of numbers that works is 4 and 2. And then the factorization becomes x plus 4, x plus 2. Let's talk about two special shapes, the difference of cubes and the sum of cubes. These factor. Their factorizations are similar. They're not the same. Here's what's similar. They both have this in common. X cubed minus a cubed factors this. We need to fill in the signs. And x cubed plus a cubed factors as this. This part is the same. What are the signs, though? And this is difference of cubes. What you can use to remember the signs is the mnemonic SOAP. What does that stand for? Same. So the same signs, this is still minus, this is still plus. This is the S. O stands for opposite. Difference of cubes. This is a plus. Here it's a sum of cubes. This is a minus. And AP, always positive. Plus in each. Those are the formulas for a difference in sum of cubes. Let's do an example. Let's do a sum of cubes. This is this number, problem 34. Factor x cubed plus 125. And we can think of this as a difference, or excuse me, a sum of cubes, x cubed plus 5 cubed. Let's write down the sum of cubes formula. I'll use the letter A, since it hasn't been used in this problem. This factors as x plus a. So tell yourself here what is the value of a. You're applying the formula to x cubed plus 5 cubed. That means a is 5. So we can take our general formula, replace a by 5, and we get our factorization. 5 squared is 25. We want to write 25 here. This is what we would key in to the software.